Hello to all my Chem 9 students. I hope this finds you doing well. Today we're going to do a couple of recordings on Chapter 6, and this one's going to be all about chemical bonding and why elements combine together to make the materials that we know. So we are going to need a periodic chart, so make sure that you pull one of those out. If you don't have the one that I gave you in class, there is one in the back of our planner that's exactly like the one I gave you in class, and that would be an excellent one for you to use. So our essential question today is, how are the families and valence electrons connected? So make sure you put this in the next page open in your notebook. And the valence electrons are the electrons in the outermost energy level. Now, it's been a while since we've talked about a Bohr diagram, but that's what this is going to lead into. And we will take a look at that today. We'll revisit some of that. So the first thing is we need to define a valence electron. Okay, so valence electrons are electrons in the outermost energy level. Okay, so electrons in the outermost energy level, this helps us tell how reactive an element is, how well it can bond with something else in those outer energy level electrons, whether they are going to move or not. So the valence electrons are equal to or the same as the family number. And as I already said, that these electrons are very important in bonding. Okay, so what I'd like you guys to do is we are going to mark this up on our periodic chart. So I'd like you to go to your periodic chart, as you can see that I've done here, and we are going to put the number of valence electrons. So this number keeps going to every time I change, it doesn't hold my thickness of my pen here. So we're going to put valence electrons. So squeeze that in somewhere. And the valence electrons here for hydrogen, or everything in this family, is 1. And then everything in this family is 2. And then we're going to skip all these transition metals in the middle. And the boron family has 3 valence electrons. Carbon has 4. The nitrogen family, remember families go up and down, has 5. Oxygen family has 6. Fluorine is 7. And the helium family goes up and down, is 8. And you might want to draw a little note that this is called a family or a group when you go down. Okay, so a family or a group. So when we talk about a certain element, we could say aluminum, how many valence electrons? It has 3. That tells us how reactive it is. The ones that have over here, sodium has 1, magnesium has 2. Those are very reactive elements because they don't have very many electrons in their outer shell. They want to bond. Okay, so the next thing I want you guys to do is, I should have kept it on here, I want you guys to focus on fluorine. And you guys can see that if we focus on fluorine, that it has atomic number of 9, and that bottom number rounds to 19. So let's put that next into our notes, that we are going to do an example of fluorine. So fluorine atomic number again is 9, its symbol is F, and the bottom number rounded is going to be 19. So let's remember that this is going to tell us, because the top number is the atomic number, that tells us that we have 9 protons and 9 total electrons. And then here, to get the number of neutrons, we are going to take 19, subtract 9, and that's going to give us 10 neutrons. So if we draw our little Bohr diagram, you might recall that there's protons and neutrons in the middle. So we have 9 protons, we have 10 neutrons. Like I said, I know this has been a while. Then we have a total of 9 electrons that we need to put in the energy levels. So we are going to say that there, you can just go ahead, sorry, draw 2 energy levels, got distracted there. And then we will go ahead and we are going to put the number of electrons in our diagram. If we recall that only 2 electrons can fit in the first energy level, and then it's too small and it's filled up, and the next level can hold 8, but we only have 7 more to put in. So 1, 2, 3, 4, 5, 6, 7, and that gives us a total of our 9 electrons. So our outer shell, this is our outer shell, or our number of valence electrons, has 7 electrons. So what this is going to do is it's going to lead us, into our electron dot diagram. And the electron dot diagram is going to just help us figure out everything on the outer side, how it's going to bond. So electron dot, and each dot, whoops, sorry about that, using a new device and I'm still figuring it out. Each dot represents 1 valence electron. Okay, so 1 valence electron. So how we are going to draw this is, let's just say we have element X. We don't really care what element it is. And if you have 1 valence electron, you are going to put it there on that side. So 1 electron here, 2, 3, 4, 5, 6, 7, and 8. So all that means is the number of electrons that are there, they're going to follow that kind of pattern so that when we do the next step for bonding, it'll make more sense with that. So we said with fluorine that we had 7 valence electrons. So I would draw my element F, and then I can go ahead and put my electrons around the outside. It has 7. So 1, 2, 3, 4, 5, 6, and 7. So that's where the 7 dots would go. The extra one that's down here, that's not there, it wants 8. It wants to fulfill the octet rule. It's not there, and so fluorine has ability to make 1 bond. That's what that's going to tell us. So if we take a look at lithium, let's go back to our periodic chart. Here's lithium right here. So it has 1, I'm in family 1, so it has 1 valence electron. So that's all I would do to draw its electron dot diagram, is I would draw the element Li, and then it has 1 valence electron. That's it, okay? All right, and then we're going to talk about how these things are going to bond together. Okay, so I think I'd like you guys to go ahead and draw your line here, and this will be our summary. All right. So we're just going to go on to a couple more minutes here. I'd like you to find another clean page. And this time, our essential question is going to be about how they bond. So our essential question is, how do atoms bond? And the reason they want to do that is they want to bond to gain stability. Okay, so atoms are stable when they have filled outer energy levels or they fulfill the octet rule with 8 total electrons in their outer energy level. So if we think about those noble gases on the far right of the periodic chart, they already have 8 total electrons in their outer energy level, so they don't want to bond with anything. Okay, so how they become stable is by gaining or losing electrons, and they want to gain the 8 total electrons. So how they do that is they are going to become ions. you've probably heard me say that term a lot in class, is that an ion is something that gains or loses an electron. So the first part that we're going to say is if they are a cation, okay, that means that they have lost electrons, and these are metals, okay? Metals easily lose electrons to become stable. Now here's the part that's really difficult to understand, is we have to remember that electrons are negative. If we lose them, that means there's more protons there, and they become a positive charge. So a cation is positive. And how they do that is if we take a look at magnesium. So if I go back to my periodic chart right here, I can see that magnesium is right here in family 2. So it has 2 valence electrons, okay? If we think about it, if it wants, it's a metal, so it wants to lose those 2 electrons, it has an atomic number of 10, or 12, sorry. When it loses those 2 electrons, it's going to look like neon that has 10 over here. That's why it's going to lose those 2. So let's draw that up. Looks like I'm on this page here. Okay, so magnesium, in its natural state, it has 12 protons and it has 12 electrons, okay? Now to become stable, I just told you that it wants to lose those 2 electrons. So when it becomes an ion, it has, yes, I'm recording. It has 12 protons, and then if it loses those electrons, then it's going to have 10. So then it has a positive 2 charge. And that's how we would write this, is it's Mg plus 2. And that's called a superscript. Okay? And then we can show it on the other side that if it is going to gain electrons, then it's going to become an anion. Okay? And an anion has a negative charge because it's going to gain electrons. And remember that because it's going to gain, it means that it's gaining electrons which are negative, so it's going to make it overall negative. And so nonmetals, the ones on the other side of the chart, they want to gain electrons. Okay, nonmetals want to gain electrons. So if we do the same thing that I just did, if we say we have oxygen, oxygen has 8 protons and 8 electrons, how you find it on the periodic chart. It really wants to become an ion by gaining 2 electrons. So then if it has 8 protons and then it gains the 10 electrons, I add that up and I'm going to get an overall charge of -2. So then I have oxygen with a -2 charge. Now I think you can see then that if I add these 2 together, I get Mg plus 2 and oxygen minus 2. Well, magnesium is going to give 2 up, oxygen is going to take them in, and I am going to get the formula MgO, which is magnesium oxide. Okay, that is the end of those notes. So I hope you can draw the line here and write summary. I would go back and annotate these notes and write some questions and highlight them. You guys have an awesome day.